Guess tightening a bolt is a gamble you usually lose. Apply too much unmeasured force, and the metal simply gives way. Fastening a joint isn't about pulling until it feels tight enough. It requires a highly specific measurement of rotational force, called torque, which dictates exactly how far a bolt stretches to safely clamp parts together. If you apply too little force, the bolt lacks the tension needed to hold the assembly. High-frequency vibrations on the track will work those loose nuts completely off the studs, turning a wheel into a high-speed projectile. Apply too much force, and the damage is immediate. You will permanently strip the threads right out of the hole, warp your brake discs, or crack cast aluminum engine housings. To eliminate that guesswork, we use a torque wrench. When used correctly, it applies the exact amount of clamping force required by the manufacturer. Achieving that perfection comes down to 3 golden rules. By strictly adhering to these rules, you ensure your assembly performs exactly as engineered, rather than driving a ticking time bomb. Rule number 1 is to set the tool to the exact specification. You must check the service manual or the data plate for the required number before you touch the wrench. But having a number isn't enough. You have to verify the unit of measurement. The single most common point of failure is confusing Newton meters with foot-pounds. This diagram shows exactly why that mistake is dangerous. 100 foot-pounds is equivalent to roughly 135 Newton meters. If your manual calls for 100 foot-pounds and you set your wrench to 100 Newton meters, you are leaving that joint dangerously loose by a massive 26% margin. To lock in your spec on a standard click-type wrench, you twist the handle base. You have to align the 0 marker on the rotating grip perfectly with the target specification line etched into the main shaft. Alternatively, digital torque wrenches remove the manual alignment entirely. They let you select the unit and display the exact measurement directly on a digital screen. A precision tool cannot protect you if it is fed the wrong data. Dialing in the precise unit and the precise number is the absolute foundation of your mechanical safety. Rule number 2 covers your physical technique. Start by placing your hand dead center on the grip. Moving your hand up or down the shaft alters the tool's designed lever arm, which alters the final torque delivered to the bolt. Once your grip is set, apply force in a completely smooth, continuous motion. Jerking the handle builds momentum that will easily overshoot your target. As you apply steady pressure, wait for the tool's feedback. Depending on the model, you'll either feel the head deflect slightly, hear a mechanical click, or get a digital beep from the handle. Firm, the exact millisecond that signal happens, you stop. You freeze your arm and release the pressure entirely. A torque wrench does not physically stop the bolt from turning. Applying even a fraction of an ounce of extra force past the click instantly overrides the tool's internal mechanism and over-torques your joint. The meticulous engineering inside that steel tube is entirely dependent on your personal discipline to stop pulling on command. Rule number 3 dictates the sequence of your clamping force. For decades, complex multi-bolt assemblies like cylinder heads have required a strict tightening sequence to prevent the metal from warping as it gets clamped down. This graphic shows the required criss-cross method, commonly known as a star pattern. You never tighten bolts in a simple circle, as that pushes the component off-center and binds the metal on one side. You must also work in stages. Following the star pattern, you make a first pass at half torque on every single bolt, and then you complete a final pass at full spec. This staged approach gradually draws the 2 pieces of metal together, ensuring that large components, like wheels or cylinder heads, seat perfectly flat against their mounting hubs. Perfect clamping force requires a balanced distribution of pressure across the entire joint, rather than just isolated tightness on a single bolt. Keeping your torque wrench accurate requires knowing its physical boundaries. This is a delicate measuring instrument, not a heavy-duty tool for breaking things loose. The explosive, jarring force required to crack a seized bolt loose will instantly destroy the sensitive internal mechanisms of a torque wrench. Use a dedicated breaker bar or an impact gun for disassembly. When the job is done, a standard click-type wrench requires a simple but mandatory storage procedure. You must twist the handle setting all the way back down to its lowest edged marker. Leaving the tool dialed up keeps the internal mainspring under constant compression. Over time, that metal spring fatigues, permanently ruining the calibration accuracy of the tool. Storing the wrench properly, wiping it down, and calibrating it regularly are the hallmarks of a disciplined workshop that respects its equipment. By respecting the tool's limits and strictly following the 3 rules of torque, you guarantee perfectly seated joints, pristine threads, and total mechanical reliability every time you turn a wrench.